Good day viewers. In this episode, we are going to look at two specific scientific myths, that is, absolute zero anything, and infinity anything. The question you should be asking now is, why are we classifying these well-accepted limits as being myths? Well, the answer should be obvious, but let me walk you through the logic. Firstly, they have never been experimentally verified for any situation, hence, they cannot be considered as anything other than mythical. Secondly, they cannot even be considered as theoretical limits because they cannot accommodate Heisenberg's uncertainty principle. Thirdly, this means that absolute zero anything or infinity anything cannot have any error or approximation associated with it. Absolute zero anything must be exactly and precisely zero. An instrument must be able to measure absolute zero anything to an infinite number of decimal places. Similarly, infinity anything must be measurable as being infinity to an infinite number of decimal places. This is clearly paradoxical. The bottom line is that it is physically impossible for humanity to build instrumentation to experimentally verify these limits. Of these two myths, the most invasive and problematic to fundamental physics is absolute zero anything. Infinity anything is also problematic, but it is often interpreted to mean that some kind of error has occurred in a derivation process. However, I should point out that division by zero is commonly and incorrectly interpreted by many physicists as infinity. However, division by zero is actually undefined, not infinity. It is quite surprising how many physicists make this mistake. Okay, let's now take a deeper look into the absolute zero anything problem, starting with the most famous candidate, that is, massless photons. So, do massless photons really exist or not? Well, the standard physics position is that yes, they do really exist. This is largely due to Einstein's famous E=mc² equation, which we discussed in episode 77. However, the particle data group provisions for the existence of massive photons, possessing a non-zero mass, below the threshold value appearing on screen. Please refer to episode 6 for more information. It is important to note that in 2005, Storti published an exact analytical solution for the mass energy of a photon, satisfying the mass energy threshold published by the particle data group. Hence, we have arrived at the famous photon-wave-particle duality, that is, Einstein requires photons to be waves, but the particle data group provisions for photons to exist as particles. So then, which one is correct? Well, we showed in episode 77 that Einstein's famous equation may only be experimentally verified to be an approximation, due to the Heisenberg uncertainty principle. Therefore, the obvious question now becomes, is there some way to settle the wave-particle duality dispute? Well, we believe there is, and we are going to look at that next. In 2007, Storti published a treatise whereby the power spectrum Hubble constant was derived in exact analytical form, appearing on screen as h⁻⁵. In 2008, the Australian Institute of Physics also published the Storti 2007 result. In the same year, the particle data group value for the Hubble constant was significantly higher than the published Storti 2008 result. In fact, in 2008, the particle data group did not formally recognize the difference between the measurements of the power spectrum Hubble constant and the cosmic distance ladder Hubble constant. However, in 2008, Storti calculated the power spectrum Hubble constant, not the cosmic distance ladder Hubble constant. Storti was able to achieve this by constraining the Hubble constant to the cosmic microwave background radiation. What this means, quite astonishingly, is that Storti predicted the existence and value of the power spectrum Hubble constant 5 years in advance of experimental confirmation via the Planck satellite in 2013. Moreover, in 2023, Storti correctly derived the experimentally observed values of cosmic distance ladder Hubble constant, pertaining to red giants and Cepheids. Storti achieved these impressive results, utilizing the same equation describing the power spectrum Hubble constant. This means that the riddle of the Hubble tension has been completely resolved. In fact, his results clearly demonstrate that the so-called Hubble tension is to be expected, it is not a mystery. Consequently, the standard model of cosmology is not broken, and everything is fine. Please refer to the cosmic microwave background radiation constrained Milky Way mass link appearing at the top of the screen, for access to the associated research article and the formal derivation resolving the so-called Hubble tension problem. What is particularly important to notice on the slide is the inclusion of the photon mass energy term, as emphasized by the purple bar. Without its exact analytical solution being derived by Story in 2005, then no form of experimentally verified Hubble constant could have been predicted. In other words, this slide emphasizes the cosmological significance of massive photons, that is, it emphasizes the particle data group provision for the existence of non-zero mass photons. Okay, so this is impressive evidence for the existence of massive photons, but is there any more evidence? Well, yes, there is. We will have a look at this on the next slide. In 2020, Advances in Astronomy published the experimentally verified Story values of dark energy density parameter and power spectrum Hubble constant, as emphasized by the red boxes. What is impressive about this is that the derivation of the dark energy density parameter utilizes the power spectrum Hubble constant appearing on the previous slide. Hence, this is more compelling evidence for the existence of massive photons. So now, we have a situation whereby two key cosmological parameters have been predicted and experimentally verified, utilizing two completely disparate mathematical equations. However, the core feature linking these two equations is the photon mass energy derived by Story in 2005. Could this just be coincidence? Well, we believe this to be unlikely, but what other evidence can we provide to dismiss the possibility of coincidence? To address this question, the historical sequence of events becomes significant. Permit me to explain. The results appearing on screen were published in 2020. The James Webb Space Telescope started collecting useful data at scale around the middle of 2022. This means that the cosmological age predicted by Story, as emphasized by the blue box, was published approximately 2.5 years prior to the James Webb Space Telescope, largely collecting scientifically meaningful data. However, evidence is now mounting that the standard model of cosmology value of cosmological age being 13.8 billion years old, is now in jeopardy, due to the formation and maturity of significantly massive galactic structures, so soon after the Big Bang. This observation was completely unexpected by the standard model of cosmology. The most obvious explanation for this quandary, although not yet widely accepted, is that the standard model of cosmology calculation of cosmological age is incorrect. The Story value of 14.57 billion years, which is exactly equal to the Hubble age, adds many hundreds of millions of years to the age of the universe. The addition of this extra time fixes the large-scale galactic structure problem identified by the James Webb Space Telescope. Therefore, the formation and maturity of significantly massive galactic structures is to be expected, and no standard model of cosmology surprises actually exist. Everything is fine, and all is good with the standard model of cosmology. Let's now summarize what we have learned. The lessons learned in this episode are quite straightforward. 1. The experimental validation of absolute zero anything, and/or infinity anything, is a technological impossibility due to the Heisenberg uncertainty principle. 2. The two extremities in nature which cannot physically exist are absolute zero anything, and/or infinity anything. 3. Our experimentally verified predictions and results confirm that photons are massive, they are not massless. Photon mass is small, but it is non-zero. 4. Photons are best described as particles, but photonic waves are best described by vast populations of photonic particles, moving coherently. 5. Absolute zero anything, and/or infinity anything, are not even theoretically possible, they can only be mythical.